Hello, this is the solution to number 30 on the lecture notes where the penguin perhaps falls to doom, okay? Or gets pulled to doom or whatever. Okay, so I answered number 30 part A. Up here you'll see that there's the force of gravity, and that's equivalent to m1g. There's also tension, there's the normal force. Here there's the force of gravity acting on the block, which is equal to m2g, and here's the same magnitude of tension but pulling upward on the block. Okay, so it asks us what the acceleration is of this system. Also, another thing that you may want to keep in mind is that on the incline we're going to look at the axis a little bit differently. We're going to look at it like sort of our inclined axis, so you can look at it like right here. So and something that you may want to note, you can check in the lecture notes like why this angle here is equal to that angle there. If you have a question, come on by or check your lecture notes. There should be a decent-ish diagram of that. Okay, so it says what's the acceleration of this system? I think that we can say that the only real things that are contributing to the net force acting on this stuff is that there's the force of gravity over here and tension. There's tension pulling on the penguin, and I would say that these y components of the force of gravity, we'll call this FGY, which is really equal to FG cosine theta, that is really balanced out by the normal force, because this thing is not going to accelerate into the incline or start floating up from it unless there's some serious craziness going down. Okay, so I think that really that what we can say is that the things that are really contributing to the net force on the penguin is this x component of gravity, which I hope you're not offended if I say that's FG sine theta. Oh, and by the way, Fg is m1g. Okay, and so I think that we can say that like this thing is either going to slide down the incline or penguin's going to slide over the cliff. And I think that something that's important to do is let's look at this as a one-dimensional motion problem, even though it doesn't really look like it, but it really can go one way or the other. I'm going to make over the cliff positive because I think that would be a positive thing for the penguin to experience that. Okay, so now let's sort of write down what we know. We know that the tension minus the x component of gravity, Fgx, is equal to, those are contributing to the net force on the penguin. What is the net force going to do? It's going to accelerate it. Okay, how much? Well, it depends how massive the thing is. All right, so it's going to accelerate it according to Fnet equals ma. Now, what about the block? We also know that, so let's just write it down, okay? We know that m2g minus tension, those are the two forces that are applying the net force to the block. What's that going to do to it? Well, it's going to accelerate it according to what? m2a. Are these both the same a? Yes, they absolutely are, because they're connected, and if one moves a certain way, it's going to move the other thing that certain way. Okay, so now the next thing we do when we solve problems is I'm just going to rewrite these things. We want to try and minimize the number of unknown variables we have. So I'm going to rewrite each of these equations. T minus m1g sine theta equals m1a. I'm going to rewrite the second one, which already seems to be sort of minimized with the unknown things. And what I'm going to do is now we have two equations, and you'll notice that we have two unknowns. I'm going to just add these equations together because that gets rid of the tensions here. So you end up getting m2g minus m1g sine theta equals m1a plus m2a. Okay, and now let's isolate the a. Yay! So you should end up getting, once you factor out the m's, actually we'll stop there. Okay.